Drag an ice cube across a sandbox, and it leaves a scraped groove behind. Let a second ice cube just melt in place, and it leaves nothing but a damp patch. That difference is the whole story, and it goes further than you'd think. Because a glacier isn't ice sitting still. It's ice that moves. Glaciers are rivers of ice. Under their own enormous weight, they flow downhill, however slowly, dragging rock and debris along their base the whole way. And because that ice is dragging real material across real rock, it doesn't just sit on the landscape, it carves it. A river cuts a narrow V-shaped valley. A glacier grinds out something wider and rounder, a U-shaped valley, plus fjords where the ice met the sea, and moraines, the piles of rubble a glacier bulldozes and leaves behind. So why does the ice show up in the first place, and why does it eventually leave? Ice ages aren't random. They're cyclical, paced by tiny, regular wobbles and shifts in Earth's orbit and tilt, what's called Milankovitch cycles. Those orbital shifts nudge how much sunlight reaches high latitudes, and over tens of thousands of years, that's enough to tip the planet into an ice age or pull it back out of one. That's an extremely slow clock. Glacial cycles operate on a timescale of tens of thousands of years, not decades. Push a little further, and glaciers turn out to matter for something else entirely: memory. As snow compresses into glacial ice year after year, it traps tiny bubbles of the atmosphere from the exact moment it fell. An ice core pulled from deep in a glacier is a direct climate record, sometimes stretching back hundreds of thousands of years. And today, that same ice is also a warning. Glaciers worldwide are retreating at rates far faster than any orbital cycle could explain, adding directly to global sea level rise. So the next time you see a glacier, remember, it's not a frozen leftover. It's a slow-moving river, a landscape sculptor, and a climate record all folded into one. And right now, it's telling us something urgent.